it is 1. So these values we have sufficiently taken. So now we are drawing the graph of this function. So here, let's see here, graph of this function. We will take 1, 2, 3, 4. This is -1, -2, -3, -4, 1, 2, 3, 4, then -1, -2, -3, -4, and so on. So see, first of all, we will draw the graph from the first one. So when x is equal to 1, y is 3, x is 1, y is 3. So here we are getting the point. X is 1, y is 3. And here x is equal to 2, x is equal to 0, y is equal to 2. So here we will get the point 0, 2 in y-axis. X is equal to -1, y is equal to, or f x is equal to 1. So -1, 1. So here we are getting the point -1 and then 1. If we were taking x is equal to -2, then y is equal to 0. So here we are getting -2 and 0. So here, if we will join this, we will get a straight line. We will get a straight line. Now, here we will draw the graph from this also. When x is equal to 1, here the condition is given x is greater than 1. When x is equal to 1, y is equal to, or f x is equal to -1. So x is equal to 1, y is equal to -1. So this point, and x is equal to 2, y is equal to 0. So x is equal to 2, y is equal to 0. So this point, and x is equal to 3, y is equal to 1. So x is equal to 3, y is equal to 1. So this, so here we are getting this one. So see, if we will draw this graph of the given conditions, so if we have to draw this graph here, then we have to lift here the pen. Without lifting the pen, we cannot draw both the graph, because here when x is equal to 1, here x is equal to 1, y is 3. So this point, and here when x is equal to 1, y is what? -1. So suppose it is depend. If we will depend or not depend, open, or I will just give the red sign. So this one and this one are not coinciding. Here is there is a jump, there is a gap. So there is a gap here. So we cannot draw the graph without lifting the pen. Here we have to lift. यहाँ से यहाँ तक आएंगे, और यहाँ से फिर हमको यहाँ आना होगा. 1 पर 3 है यहाँ पे fx, और यहाँ पे 1 पे आपका जाके -1 है. यहाँ पे 1 पे -1 है, और यहाँ पे 2 पे 0 है, और यहाँ पे आपका 3 पे 1 है. ऐसे तो यहाँ पे हमको लिफ्ट करना होगा. इसका मतलब क्या है कि द फंक्शन इज not continuous. not continuous, and at the point x is equal to 1, because at the point x is equal to 1 we have to lift the pencil or pen, whatever it is. So this is the graphical. So to draw the graph we can check also, but from the mathematics we can also check by the conditions. So from the condition I am just checking limit when x tends to 1 minus fx. 1 minus means left hand limit, means each value of x is slightly less than x. So now for that x tends to 1 minus. So for 1 minus x is less than 1, the function is given x, the value of the function is x plus 2. Now put the value over here, 1 plus 2, so it is 3. And what is the value of the function when x is equal to 1? The value of the function when x is equal to 1 is, just I am seeing the value of the function, it is also x plus 2, so it is 1 plus 2, so it is 3. But if we will see the limit x tends to 1 plus means right hand limit, this is the left hand limit and this is right hand limit. RHL I am writing fx limit. So 1 plus means each value of x is slightly or greater than 1. So x tends to 1 plus, and here is x minus 2 is the value of the function. If x is equal to x minus 2, it is given when x is greater than, when x is greater than 1, it is given in the question. In the video you can see also. So, and here it is given when x is less than or equal to 1, it is f x is equal to this, and when x is greater than 1, fx is equal to x minus 2. So if you will substitute 1 minus 2, it is equal to minus 1. See, here this is taken as 1, this is taken as 2, and this is taken as 3. So from the first left hand limit of the function is equal to, at the point x is equal to, x tends to 1 is 3, and the right hand limit of the function is equal to minus 1. So limit of the function at this point does not exist. When the limit of the function does not exist and the value of the function at the point x is equal to 1 is equal to 3, so all are not equal. So for the continuity of the function, limit of the function must exist. If the limit of the function, left hand limit and right hand limit of the function exist and both are equal, exist means both will be equal, their values are equal, and the value of the function at the same point is also equal, then only the function is said to be continuous. Otherwise the function is said to be discontinuous. Other is a condition we can write if we have to prove the function is continuous at the point x, if x is equal to a, if limit x tends to a, fx. Here x tends to a means either x is greater than a or x is less than a. Okay. Then if it is equal to the value of the function fa, then also the limit then also the function is continuous, so there will be no break. So here this thing represent both left hand limit as well as the right hand limit of the function. So now I am coming to the next example in which we will discuss about whether the function is continuous or discontinuous. So here this point x is equal to 1 for this question, x is equal to 1. See, x is equal to 1 is point of discontinuity. Discontinuity. Point of discontinuity. And the function is discontinuous function. So fx is discontinuous function where at x is equal to 1. At x is equal to 1 only the function is discontinuous. One more thing I have to tell. See, here the function is continuous because we can draw this line without lifting the pen, tip of the pen or pencil. And here we can draw this line without lifting the pen and tip of the pencil. So this is the straight line and is linear equation. Any linear polynomial, if the linear polynomial, if you suppose that y is equal to x plus 2 is given, so it is a linear polynomial, and y is equal to x minus 2 is given. So separately these and these two are representing the linear polynomial, and they represent in the graph straight line. So this is individually is continuous function, and y is equal to x minus 2 here individually is continuous function. But under the condition when at the point x is equal to 1, at the point x is equal to 1, when the condition this is given, x is less than or equal to 1, for which fx is equal to x plus 2, and x is greater than 1, for which fx is equal to x minus 2. So at this point only the function is discontinuous. But if this condition is not given, fx is equal to x plus 2 is only given, then it is a linear function. If it is given, if it will be given that x is equal to fx is equal to x minus 2 for all the real values of x, whether the linear function is continuous or not. So every linear function is continuous. So that linear function, suppose I am taking another example in which I will discuss about whether the function is continuous. So because here earlier in the first example I have taken, in which I have taken the function fx is equal to x square plus 1, that represent a parabola which is a continuous function. Now we are coming to the next. See, this is the next question I have taken. Is the function fx continuous at the point x is equal to 0? So this is a, x is equal to a, where fx is equal to cos ax minus cos bx upon x square. A and b are constant. X is not equal to 0. X is not equal to 0 means either x implies either x is greater than 0 or x is less than 0, both. But x is not equal to 0. Here, the value of the function fx is equal to b square minus a square upon 2 when x is equal to 0. So the condition is very important. These conditions are very important. So when x is greater than 0, or when x is less than 0, fx is equal to this, and fx is equal to b square minus a square upon 2 when x is equal to 0. Now we have to check whether the function is continuous at the point x is equal to 0 or not. So now I am solving. So left hand limit x tends to, here in place of a 0 minus, I have to take 0 minus means all the values of x is slightly less than 0 fx. So here limit x tends to 0 minus, it is just notation. This minus sign represents that each values of x is less than 0. This minus sign represents this. So here x is less than 0 means we have to take the function fx is equal to cos ax minus cos bx upon x square. Here not it is equal to. Therefore we can write cos ax minus cos bx upon x square. So now the limit has come. Now here limit x tends to 0 minus, as you know that I am just giving cos c minus cos d, cos c minus cos d is equal to 2 sine c plus d by 2 up into sine d minus c by 2. Here I have written, so 2 sine ax plus bx upon 2 and then sine bx minus ax upon 2. Here c I have taken ax and d bx. So it is in the form of sine c minus sine d. So here you just see sine c minus sine d is equal to this. So we can write in this way, 2 sines ax plus bx upon 2 into sine d minus c by 2 bx minus ax upon 2 and whole is divided by x square. Now you know that limit theta tends to 0, sine theta by theta, it is equal to 1 when theta is measured in radian. In class 11th trigonometric limit, class 12 student know better, as well as class 11 students also. Now limit x tends to 0 minus 2 sine, here we can take x common, we can a plus b x upon 2 divided by, we have to divide by a plus b x upon 2 because we have to make theta by theta, sine theta by theta, and multiplied by a plus b into x upon 2. And the second one, this one, sine, we will take x common, b minus a into x upon 2 whole divided by, you have to do b minus a into x upon 2, then multiplied by b minus a into x upon 2. If you are having any problem in limit, then you just comment to me so that I will make one video, 1 or 2, 3 videos in limit, or I will make also for the class 11th. So here x square is this, so here I am writing 1x and here I am writing 1x. There is a into, so this will x square. This x will cancel with this, and this x will cancel with this, and this whole thing will become what? Limit sine theta by theta 1, and this also becomes 1. So it is 2 into this a plus b upon 2. Then here is 1. Here you see this becomes limit. We can take limit over here. We can write also limit x tends to 0 sine theta by theta form. So it is 1. This is also 1. And here what is left? B minus a upon 2. And that's all. So this 2 will cancel. And a plus b is here. So this can be written as b plus a into b minus a upon 2. So this is equal to b square minus a square upon 2. So this is taken as 1. Similarly, no need to find out the right hand limit. Right hand limit will be again in the same way you have to do. You will get b square minus a square upon 2, and the value of the function at the point x is equal to 0. X is equal to 0. It is given here. The value of the function x is equal to 0. The value of the function f x is equal to b square minus a square upon 2. So see. So this is f0 is equal to b square minus a square upon 2. This is taken as 3 and this is taken as 2. So from equation 1, 2 and equation 3, we can write left hand limit is equal to right hand limit is equal to f0, the value of the function, and all are equal to b square minus a square upon 2. Therefore, x is equal to 0 is point of continuity, and fx is continuous.